All right, today we're going to pull back the curtain on modern finance and dive right into the engine room, the world of algorithmic trading. We're going to go on a little journey through the different levels of automated finance, exploring the programming languages that power everything from your first trading bot all the way to the massive systems at big banks and even the wild frontier of DeFi. So, let's start with the big question, the one that kind of hangs over this whole topic. With all our human intuition and experience, can a person, a real trader, actually beat a purpose-built algorithm? On the surface, it seems like a fair fight, right?
But maybe that's the wrong question entirely. When you think about it, modern markets are a 24/7 global machine. They move at the speed of light, and they have zero regard for human emotions like fear or greed. So maybe it's not about who's better, it's about whether a human is even equipped for the fight in the first place. And that really gets us to the heart of this explainer. We're going to look at why these automated trading bots weren't just a cool idea, but an absolutely inevitable solution to the built-in limits of human biology and psychology when it comes to playing in the financial arena. I mean, just look at the advantages. It's almost an unfair fight. A bot never gets tired, it never needs a coffee break, it can execute trades at speeds we literally can't even comprehend. It doesn't get swept up in greed or panic sell when things get choppy, and maybe most importantly, it can test a trading idea on years of historical data in just a few minutes, something that would take a human being an entire lifetime to do.
So, you want to get in the game, where do you start? Well, welcome to Level 1. This is where most people begin their journey into algorithmic trading, and it's built on one of the most popular, most accessible programming languages on the entire planet. We're talking about Python, of course. For retail traders, for students, for quantitative researchers, this is home base. Its whole vibe is about getting ideas out of your head and turning them into a working prototype as quickly and painlessly as possible. And there's a really good reason for Python's total dominance here. First off, its syntax is just simple. It's easy to read, easy to learn. But the real superpower is its incredible ecosystem of libraries for data analysis and machine learning. It means you can go from a thought to a full-on backtest incredibly fast. It's just the default starting point for pretty much everyone. Now, I've mentioned backtesting a few times, so let's just lock in what that means, because it is the absolute cornerstone of all of this. Think of it like a time machine for your strategy. You run your bot's logic on market data from the past to see if it would have actually made money, all before you risk a single real dollar. It's a crucial, non-negotiable step. And when we say a vast ecosystem, we aren't kidding. This is just a tiny snapshot of the powerhouse tools a Python developer has for free. You've got specialized libraries for chopping up data, for running technical analysis, even for building really complex machine learning models. It's like having an entire quantitative research desk right there at your fingertips. But there's always a but, isn't there? All of that simplicity and ease of use comes with a trade-off: raw execution speed. Now, for most people, this doesn't matter one bit. But if you're trying to compete in the world of high-frequency trading, well, that speed limit is a massive wall. Which brings us to Level 2. We're leaving the playground now and entering the world of big institutions. This is a place where having a good strategy is only half the battle. The other half is executing it faster than literally anyone else on Earth. This is where we hit that classic trade-off: Python versus C++. They are built for completely different jobs. You use Python to come up with the idea and test it. You use C++ to win the race. C++ gives developers direct control over the hardware, letting them wring out every last nanosecond of performance. That right there, that's a nanosecond, 1/1000th of a second. That is the time scale that high-frequency trading firms live and die by. It's about the time it takes light to travel 1 foot. In this world, a millisecond is an eternity, and C++ is the language that lets you even show up to the race. But hang on, speed isn't the only thing that matters for these huge financial systems. What if you're building the core plumbing for a bank, or the matching engine for a stock exchange? You need something that's not just fast, but also incredibly stable, secure, and can scale up massively. And that is where Java comes in. If C++ is the Formula One car, Java is the indestructible freight train that moves the entire economy. Think about the giant order management systems that have to run flawlessly 24/7 without a single hiccup. Java's entire design is built for creating these huge, secure, mission-critical systems that are the true backbone of the financial industry. Okay, so we've got our research lab with Python and our institutional-grade languages. But now it's time to level up again. Get ready for Level 3, a world where the rules are completely different. Welcome to the frontier, decentralized finance, or DeFi, where your bots are talking directly to the blockchain.
The shift here is just massive. On a normal exchange, your bot talks to a private server through an API. It's their house, their rules. In DeFi, your bot is interacting with a global, public computer, the blockchain. There's no middleman. You are always in control of your money, and the exchange's rules are just code that anyone can see and interact with.
And instead of those old-school order books, most of these decentralized exchanges, or DEXs, use something wild called an automated market maker, or AMM. It's a totally different way of thinking. Basically, assets are held in big pools of money, and the price is set by a math formula. It creates a brand new environment that needs a totally new kind of bot to navigate it.
And this new environment is evolving at a breakneck pace. I mean, we went from the simple first-gen AMMs to V3's concentrated liquidity, which let traders be way more efficient with their money. And now we're seeing V4's singleton model, which is all about making transaction fees super low. Every single step adds a new layer of complexity that bots have to understand.
So what languages do you use to conquer this new frontier? Well, out here, performance and absolute safety are everything. Rust is a huge favorite because it's built to prevent common, costly bugs, and its performance is incredibly predictable. Then you have Go, which is a master of doing thousands of things at once, making it perfect for bots that need to watch tons of data streams all at the same time. So, after our journey through these three pretty distinct levels of algo trading, what's the big takeaway? Well, it really all comes down to one simple idea: choosing the right tool for the job.
Our whole trip really boils down to this playbook. You use Python for research, backtesting, and machine learning. You grab C++ when you need to be the absolute fastest in high-frequency trading. You build on Java for those rock-solid, institutional-grade systems, and you turn to Rust or Go for the high-stakes, competitive world of on-chain trading. Each one has its place.
But here's the real secret, the way the pros actually do it. They don't just pick one language. They use a hybrid stack. They use Python's incredible development speed to research and model their ideas, and then, once they have a winning strategy, they rewrite it in a super fast language like C++ or Rust for the live execution. It really is the best of both worlds. And all of this leads us to one final, kind of big question. The world of trading is becoming more and more autonomous, operating at speeds and scales that are way beyond what any human can truly grasp. So as these bots keep getting smarter, faster, and more sophisticated, you have to wonder, who or maybe what is really in control of the future of our financial markets?